triple integrals. And today, we are about to use one to find the volume of a tetrahedron. Our plane is 3x plus 2y plus z equals 6, and our region is tucked right into the corner of the coordinate axis. Picture a room that you're standing in the corner, and the floor is the xy plane. One wall is the xz plane, the other wall is the yz plane, and a flat surface is stretched across the corner. The space trapped between the board and the corner, that is our tetrahedron. 4 flat faces, 3 along the walls. 1 is our plane. First, where does this plane hit each axis? These points will form the corners. First, the x-intercept. Set y and z to 0. 3x equals 6, so x equals 2. Corner at 2, 0, 0. Y-intercept. Set x and z to 0. 2y equals 6, so y equals 3. Second corner at 0, 3, 0. Finally, the z-intercept. Set x and y to 0. Z equals 6. Corner at 0, 0, 6. So, we have 4 corners. The origin and 1 point on each axis. The shape is now fully defined. Before the big calculation, a quick sanity check. There's a known formula for this type of tetrahedron. Volume equals to A times B times C divided by 6, where A, B, and C are the intercept lengths. Here A is 2, B is 3, and C is 6. So the volume is 2 times 3 times 6 divided by 6, which gives 6. So we expect the answer to be 6. Now let's prove it properly, using a triple integral. Volume is the triple integral of 1 over the region. We're literally counting microscopic cubes inside the shape. For z, we solve the plane equation. Z equals 6 minus 3x minus 2y. This gives the height above the base. For y, we project onto the xy plane. So y goes from 0 to 3 minus 1.5x. This forms the triangular base. For x, it just goes from 0 to 2. That's the full width of the base. Putting it together, and this is what our integral looks like. 3 nested integrals. All limits come from the geometry, and now we solve. Inner integral first with respect to z. Integrating 1 gives z. Evaluate at the limits. Result, 6 minus 3x minus 2y. That's the height of the shape at any point xy. So now, the triple integral becomes a double integral. 1 dimension is gone. 2 more to go. Middle integral with respect to y. Treat x as a constant. Just carry it through. The antiderivative is 6y minus 3xy minus y squared. Now we evaluate at y equals 3 minus 1.5x. Let's expand carefully. The first part becomes 18 minus 9x. The second part gives negative 9x plus 4.5x squared. And the third part becomes negative 9 plus 9x minus 9 over 4 x squared. Now we combine everything. Constant terms. 18 minus 9 gives 9. X terms. Negative 9x minus 9x plus 9x gives negative 9x. And x squared terms. 9 over 2 minus 9 over 4 gives 9 over 4x squared. So the expression simplifies to 9 minus 9x plus 9 over 4x squared. We're down to a single integral now. Last integral with respect to x. Integrate term by term. Antiderivative is 9x minus 9 halves. x squared plus 3/4 x cubed. The 9/4 over 3 simplifies to 3/4. Check it. Plug in x equals 2. 9 times 2 is 18. 9/2 times 4 is 18. 3/4 times 8 is 6. So we get 18 minus 18 plus 6. Everything cancels, except 6. So the result is 6. Quick recap before the final answer. Intercepts: x equals 2, y equals 3, z equals 6. We set up the triple integral with those limits. Integrated in order z, then y, then x. The z integral gave the height. The y integral simplified it to a quadratic. And the x integral brought it all down to a single number. And the final answer is, the volume of the tetrahedron is 6. Exactly what the geometric formula predicted. And the integral confirms it step by step. 3 nested integrals. 1 clean result. If this helped you, make sure to subscribe, like, and share so you don't miss more of this. See you in the next one.